Welcome to the session, the track 5, the STEAM education. So we start the session with the first presentation from Shari Metcalf
from
USA, Harvard University, with the title Shifts in Students' Attitudes and Beliefs About Science, Truth, Extended Play in an Immersive Science Game. Can start.
All right. Hello, everybody. Let me share my screen. So yes, my talk is on looking at students' attitudes and beliefs about science through extended play in an immersive science game. And my name is Shari Metcalf. I work at Harvard University in the Graduate School of Education. And my co-authors are David Gagnon at the University of Wisconsin and Stefan Slater at the University of Pennsylvania. Stefan is a graduate student of Ryan Baker, who is the third PI on this project. We're funded by the National Science Foundation through a collaborative grant to myself, David Gagnon, and Ryan Baker at the University of Pennsylvania. So to give an overview of what I'm going to be talking about today, I want to talk about the design of immersive environments for science learning. And to be clear, I'm focused here on actional immersion. So immersion through actions, empowering the participant in an experience where they can initiate actions that would be impossible in the real world and that have novel, intriguing consequences. That's a quote from my colleague, Chris Dede. And I'm going to be presenting a game that we've developed, which is called Wake, Tales from the Aqualab, which is a middle school science game focused on science practices. So those are middle school, 7th grade, around 13 years old students in science class. And in order to access students in schools, rather than developing something that's a big virtual reality or augmented reality or some of the amazing things that we've been seeing at this conference, our game runs on laptops and Chromebooks in a browser, but that makes it accessible across many schools, many students, and easily adopted by teachers. And again, the immersion in the game is through students feeling immersed in the world of the game that they are playing. So I'm going to describe pilot testing of the game last year, and specifically looking at how impacts on student attitudes about science and on engagement. And then I'm going to talk about the next steps with the project. So a little bit of background. Everybody at this conference already gets it that immersive environments are so powerful because we can virtually represent experiences that would be otherwise inaccessible. And for learning, this fits so well with the constructivism philosophy, the idea that learning is an active process gained through experience and interactions, and the idea that using a constructivist approach, what we want is to put students in situations where they have to do the interesting work, which I love that quote. And that's what it's all about. Not just showing kids things, not just telling them things, but making them do it. And that by doing it, they're learning it. And this also goes very well with the theories of situated learning. The idea that in order to support learning, learners need to be situated. They need to be in rich, authentic environments where they can repeatedly engage in the things that they're trying to learn. So for science practices, learning how to do science, we want students to be able to repeatedly engage in doing science and studying science phenomena. And that's what this immersive game can do. They can engage in actively learning with simulated environments and tools. So before I get into the specifics of how we designed the game to promote these feelings of immersion and authentic experiences, I want to give you an overview of the game. It's a long form game designed to be played over several days or up to 2 weeks. Students play as a newly launched research scientist with their own ship and submarine, but they need money. So they travel around to different ecosystems, talk to virtual scientists who might have jobs for them to do in different ecosystems to investigate science phenomena. And there's a focus in the game on 3 practices that students will do for all of these jobs. They get to do different kinds of experiments, they get to build models, and they get to make science arguments where they make a claim and support it with evidence from the data that they've collected. So this again is a pilot version of the game, but we had built out a lot of it already. So there were 35 different jobs across 4 different ecosystems: a kelp forest, a coral reef, a bayou, and the Arctic. So here's a screenshot of the game where the student is piloting a submarine in a coral reef, and they're able to click on the different organisms to learn what they are and collect information about them. And here's one where the student is exploring a kelp forest. Here's a cross section of the ship, so they can take their sub back to a ship. This is obviously just placeholder artwork, but this is what we used for the pilot. Students can visit the different rooms of the ship. One room for doing experiments, one is the modeling lab. The office is where they communicated with scientists to take on jobs and report back on their findings. And the helm lets them navigate and travel to different ecosystems. And here's an example of an experiment. This is a tank, an observation tank where students have put three organisms, kelp, urchins, and otters in a tank to see what eats what. And then by clicking on those circles, they have now evidence that, for example, urchins eat kelp, and that gets saved to their science notebook where all of their facts go. So that's a really quick overview. I'll be showing you more about the game as I go, but I want to emphasize 3 parts of the design of the game that focus on science learning. The opportunity for role play, having authentic experiences, tools, and challenges, and opportunities for self-directed learning. So the first is role play. Role play involves taking on a virtual identity. So in the game, students role play as a young scientist who's traveling to different research stations to do science work for hire. Role play has been found to increase feelings of immersion. And in science, it can help students feel more like a scientist and contribute to a sense of science identity. I could be a scientist. I'm being a scientist in the game. So here's a screenshot where a scientist at the kelp station is communicating with the student. Oh, a visitor, welcome to my research station. And then presents a job board where students can select a job that they want to do. At the beginning of the game, the first job is about welcome to the kelp forest. And so students might take on that job. And then later on, after they go out and collect the information, do the experiment, they again communicate with the kelp researcher. Thank you for your help. What did you find out? And here they present their findings. So asking for evidence, what about the food web between the organisms, and they select issues from their notebook. So in all of this, the student is being a scientist, doing what a scientist does, communicating with other scientists who treat them like a scientist. The second design component that we focus on is making it authentic, which I already said is one of the most powerful things that we can do with immersive environments, making it feel real. So by letting students virtually become a science, they can collect the data, they run experiments. students are able to both learn science and learn what scientists do. And we know that these kinds of authentic experiences can impact learning and also engagement and interest in the activity. So here's another job that a student might take on. If they go to the Arctic, they find out that there's a missing whale. Can you go and find the missing whale? And so students might dive into this Arctic ecosystem and explore. And as they get further, they discover, and we tried to provide these scenes of like, awe or amazement. This is the skeleton of a whale that is being decomposed by some of the underwater decomposers in an ecosystem, including really interesting, creepy things like zombie worms. And this is all absolutely real. And this and all of our jobs are based on actual phenomena and that are in the world and things that people are investigating and what scientists are doing. Is this? I don't know if that was. So, and then the third point that I wanted to make was on self-directed learning. So the students can choose which job they want to do. Self-directed learning, freedom to work at their own pace, having choices about what they do has been shown to increase students' motivation and interest, leading to greater achievement. Letting students explore and have agency is associated with increased motivation, and having autonomy, a sense that you're in charge of your own actions, also supports feelings of competence and of belonging. So by building this in where students decide which station they're going to go to, what job they're going to take on, in what order are they going to upgrade their sub and add new tools. So as students complete jobs, they earn money and they can use the money to buy new tools, fancier experiment tanks or flashlights so they can explore on the deeper depths of the ocean. And then those upgrades will then unlock new jobs for them to do. So it's very game-like, it's very fun. So for our pilot study, we work with 5 teachers, about 250 students who played the game for 3 to 4 hours over 6 to 8 class periods. And we gave the students a pre-post survey with 3 constructs. One, it was science self-efficacy, interest in science, and science identity. And so each of these was measured through multiple items on a validated survey using a 6-point Likert scale. So for example, students were asked, how confident are you that you can investigate what causes change in an environment on a scale of 1 to 6? Or how much do you agree or disagree with these statements? I am interested in learning about ecosystems. And then we also observed in the classroom and conducted interviews and surveys. So quantitative findings, we found significant gains in all 3 measures, and here are the numbers, but we saw increases in student-reported self-efficacy in science, feeling like they could do what scientists do, increases in science identity, feeling like a scientist, and increases in interest in science, feeling that they were interested in and wanted to learn more about science. And then we also talked to a selected sample of students and when we asked them, what did you like about the game? Their answers showed the same kinds of things that that were the design features that we were interested in. So that was exciting. So for example, students said, I liked how it talked to you as if you were a professional scientist and not just a kid in a classroom who's playing a game. The students said, other games just do it all for us. In this game, we do the work. As I'm doing this, I'm realizing, can you guys see are you seeing just the slides, or are you seeing like your own faces and stuff? Because I realized I didn't know if that was happening. Okay. Students saying what they liked about the game is that you get to go around and do missions instead of the teacher saying, read from this, write how this thing is, blah, blah, blah. So it was more independent and free thinking. And another student, a teacher reported that her student said, I really feel like a scientist. I can't believe this is what scientists do because I'm doing it and I'm figuring out on my own. So really they're speaking to self-efficacy there. Next steps, we have completed the game and are ready to, or have just released it to the public on February 1st. It's available on BrainPop and PBS Learning Media, as well as on our own website. We have the final art and full fidelity interface for all the game mechanics, and we've added a narrative, a storylines, over a dozen characters. There are dreams, a personal journal, and lots of other game elements that make you feel suspense and awe and mystery. And we've added, and we've front loaded Latinx and other minority characters. And in fact, they speak a little bit of Spanish. And so we're adding that element to the game. And next week, we're starting a new classroom study with actually those same teachers and a new crop of students who are going to be using the full game. So that is my presentation. I may have started a little late. I did want to give you the link to our game. And if I can have a minute, I wanted to show a little bit of the full interface trailer for the game. Okay.
Hello, Shari. Yes, but only 1 minute, okay? Little, yeah. Okay.
Sure.
Okay.
Just to give you some of the graphics and the new features of the game. This is a really quick trailer. Okay, so that's some of what the game is, and you're welcome to check it out for yourself. It's available for free. Thank you.
Thank you, Shari. The participants, the Halek and Susan, ask for you share in the chat the link for your game. Is possible?
Yeah. Why am I? Okay, there we go. Yes, the link for the game. Yeah, absolutely.
Yes. Thank you so much, Shari. It's very interesting game. Well, any questions for Shari? Some participants, you can ask something for Shari.
And here's
Yes, Susan.
Hi, Shari.
Hi, how are you?
I'm good, thanks. Wow, what a wonderful game. I just have a question, not about the game, but about the process. So I'm wondering, I'm seeing lots of activities and games and things like this directed at middle years, and I'm wondering why STEM is being directed at middle years so often.
Well, in my experience, it is kind of a sweet spot because there's more flexibility with most middle school science curricula to innovate and do different things. Once you get into high school, the curriculum tends to be a lot more structured. There's 1 year of chemistry, 1 year of biology, 1 year of physics, you know, leading towards, you know, specific standards. I think that's probably part of it. Also, that if you get them in middle school, then they might be more inspired to take those high school classes, take those AP classes.
Right, right. That makes sense. My own project is actually middle year STEM for my master's. I'm wondering why people aren't starting younger, even though I am not.
Oh, well, no, I've seen elementary as well. So
Have you? I haven't seen a lot for elementary. Love the game, and I'm definitely going to check it out.
in fact,
Thank
there are
you so
teachers,
much.
there's some schools in Connecticut that have been using Wake with 3rd and 4th graders, and the kids love it too. So
Oh, wonderful.
it
Wonderful.
is flexible.
Awesome. Thank you.
Yeah.
Danielle, can
you.
I ask a quick
Yes,
question?
yes, Alec. Yes, Alec.
So Shari, I really enjoyed the game. I'm just curious, are you planning to gather any learner analytic data? And if so, what type of data?
Yes, actually, sorry, I didn't mention that. For this talk, I'm focused on that little survey about affective measures, but the main focus of the game, the research that we're doing, is on data analytics and seeing what we can learn about student learning based on the paths that they take through the game. So since it's an open-ended game, students will be encountering the jobs and the challenges in different orders. And so we want to see what we can say about learning progressions based on what pathways through the game seem to be more conducive to student success.
Thanks.
Sorry, I know I went over my time, so I should probably stop.
Thank you,
and-
Shari. I have questions, but I think we need to move for another presentations. Well, it's an amazing game. My question is about self-directed learning, but we can continue this discussion.
Yeah,
in
happy to talk later.
Yes, many thanks. So we move to the second presentation. Is from Germany with Stefan Sebastian Oberdorfer from University of Hamburg, Germany, with the work Superfrog, comparing learning outcomes and potentials of Worksheet, smartphone, and tangible hardware learning environments. So, Sebastian, you can start.
Yeah, thank you for the nice introduction. Before I share my screen, I'd just like to present you the Superfrog. It isn't actually a frog, so hi to the audience. Okay, after you've now seen our Superfrog, we can now start with the presentation. So yeah, you already said or revealed the title. The research itself was also done in collaboration with Anne-Else Silke Grafe and Mark-Erich Latuschik, so greetings to them too. I'm just the only one here presenting the research. And yeah, let's start with what the Superfrog can do. So here, a first impression, you have already met Frog, but you can also open that Frog app and you can see lots of interesting markers in there. And once you use your smartphone and augmented reality, you can really take a look inside the frog, can see all its organs. You can even take out a couple of organs and inspect them up close, learn more about these organs. And you can even display some biological information about the organs to really develop a better understanding of what's going on. And yeah, this in short is basically what the Superfrog is all about. We focus on augmented reality here. So we are, of course, combining the real world, hence the real frog, or basically plush frog, not the real frog, and with virtual information like the organs that were displayed over the markers. Everything is interactive in real time, which is very important because then it's really like an interactive game exploration of that frog, or rather an interactive dissection later on, and everything is registered in 3D. So we explore a little bit the more technical side of immersion. So we are in this reality virtuality continuum, and with augmented reality, we are more on the real end side. So we are more focusing on well, combining virtual information with real world information. But of course, you can instead of using the smartphone, also go for an augmented reality HMD or something like this, And when using an HMD, of course, the immersion will be increased. So there are plenty of chances to improve. We focused on smartphones simply because smartphones are easier to obtain in a classroom setting, because we also wanted to develop the game for, at least in Germany, for 6th grade pupils, and hence it's easier to have it on smartphone than on some like the HoloLens 2 or something else, which is not that available across all the different schools. And yeah, the key attributes when we just look at extended reality when it comes to learning is all the time positive emotion, higher motivation, and a lower cognitive load, which are really important aspects when you especially want to learn some maybe more complex knowledge, like how is biology, how are the organs distributed inside of a frog, inside of a other animal. So that's definitely important that it's on the one hand very motivating to the students, and on the other hand that the cognitive load is rather low. And when we go even deeper into learning with augmented reality, we find the same thing again. So augmented reality has indicated to increase learning motivation, the performance on completing tasks, of course, the interaction, and it also allows for a direct and spatial application of the learning contents, which is, of course, quite important. And it goes into the exact same direction as we have heard just in the presentation before, with the, you can really apply your knowledge, you can really interact with things, and hence you can develop better understanding. And yeah, it gets even more interesting when you use tangible augmented reality, which is basically what I've already shown you in this small little video. You do have some actual physical objects that are enhanced by some virtual information, like with the organs we have displayed over them. So you can really grab them, turn them around, and by manipulating the physical object, you can also manipulate the virtual environment. And yeah, this makes it really, really helpful. On the one hand, it reduces the cognitive load because there's not much of maybe some mental rotation skills involved, or some other transfer skills required, because you really have your hands on the object you want to manipulate. You have definitely an increased work on the learning material because you simply grab it. It makes things easier, especially for young students, to understand how the system works, because it's simply grabbing an object and you already see what's changing. And yeah, in the end, it definitely helps to even collaborate when there are some objects and everyone wants to take a look at them when they are augmented with some virtual information. However, there are also some negative aspects, so it's easy for the students to simply just focus on the learning content, or rather the application. There might be some difficulties with handling, either on the side of the students or even on the side of the teachers. And there are also some maybe negative effect on learning outcomes for certain learners. And this basically results in the fact that there are some specific competencies needed to really integrate augmented reality into the classroom. And this, of course, increases the complexity of the preparation of a lesson, or a complete session or so. So here, really now the big question, is it really worth it to have the full-size frog, or is it better to maybe just go back to a normal worksheet environment, or to have just a normal smartphone application without these physical markers? And that's what our research is focusing on. So we developed PAUSED, the teaching frog, and we are simulating a dissection because on the one hand, we wanted to focus on this biological aspect, and on the other hand, we also wanted to reduce a little bit the ethical issues that come along with dissecting real animals, because animals have to die for it. And there's always a questionable approach about it. So we also wanted to change a little bit the world with that. And yeah, the learning environment focuses on the anatomy of frogs. The learners can acquire new knowledge, as we've just seen in the video, by taking out the heart and reading the information about the heart, and also deepen the knowledge by just trying it over and over again. We do have a quiz to assess the own learning progress. How much have I learned? What do I know about frogs? We added some gamification elements to just increase the motivation. And as of right now, we focus on smartphone augmented reality, but just porting it to a HoloLens 2 or something else would be not a problem at all. It was just, as said, a decision what is more feasible to actually integrate it into a classroom teaching setting, and not what is actually possible with technology, but it's hard to implement in the end. And yeah, the learning environment currently includes 7 organs as listed here. So the heart, liver, lungs, stomach, gut, kidney, and bladder. And the learning goal is that the learners, after having completed the application, can learn and can name and explain the organs. Here on this photo, you can even see some different versions of the environment. On the left-hand side, it's basically just the smartphone application. Then we also tried out what if we just use augmented reality without the physical elements. So here we just took a picture of that frog, and then we do have the full-size frog with all the extractable markers. And yeah, in our research now, in this particular research, we compared the plush toy with the extractable markers to a normal smartphone application. So here you do have just the normal smartphone screen where a 3D model of a frog is displayed with the exact same organs, with the exact same information as with the plush toy, but it removes the augmented reality and the tangible object aspect entirely. Finally, to have some kind of control condition, we also designed a worksheet where all the exact same information are presented, but in a typical way of using a normal worksheet that is handed out to the students so that they can go through all the information and learn by just reading the text as it is traditionally done. We came up with several hypotheses. We focus on the central aspects I've listed at the beginning of the presentation. So do the students actually learn something, or rather we expect that the learning effectiveness is higher when we use the tangible augmented reality application over the smartphone application. And then once again, the smartphone application should be better than the worksheet. And this direction is the same for all the hypotheses. Then we of course go for the emotions, that they are more positive after using the learning environments. The motivation is higher and the cognitive load should be lower all the time, with the same direction for the applications. For this to find out, we did a user study. We went to a German high school. We targeted 6th grade students, and in particular, we got 64 6th grade students. They were roughly 12 years old, and we measured the learning effectiveness with an exam. The exam was completed pre and post exposure. We measured their perceived emotion, their current motivation, cognitive load, and we also gained some feedback from the students to understand a little bit what they have felt, how they enjoyed the learning application, and in general, what they think about our learning frog. We then, of course, separated the students into 3 different groups. They were assigned on a random, well, we counterbalanced the groups and we assigned them randomly. At first, they had to fill in some demographic questionnaire, followed by the emotion assessment and the pre-trial exam. Then we had the learning phase. Here, the learning time for the augmented reality and smartphone application were reduced by 1 minute. And this is simply due to the fact that there was some kind of tutorial inside of the application for the students to really understand how to operate the learning environment. And during this tutorial, they already learned the first organ. This tutorial phase, of course, was not necessary for a paper worksheet, as this is already well known on the side of the students. So in this case, we tried to balance the learning time by subtracting 1 minute for the digital applications. And finally, after they completed the learning period, we assessed the cognitive load with the PAS scale. We asked again for the emotions, for the motivation with the KIM, and finally we did the second exam to see if they have learned something. All right, coming up with the results for the effectiveness, we unfortunately had to reject our hypothesis. So all the conditions resulted in a significant knowledge gain of the participants. So all the students knew more about the frog's anatomy after learning than before. Every time it was significant, but we did not find differences between the conditions. So there was not really a benefit of using the plush toy or the normal smartphone condition, but this often is the case when just doing these media type learning effectiveness studies, because learning is so complex, as we all agree, and we all know that it's so hard to actually find a difference between different types of media. So this was sad, but it's explainable. With respect to emotion, we unfortunately also have to reject this hypothesis. We found a higher positive effect in the with the tangible augmented reality application, but this was the only difference. So there was not really a difference between the plush toy and the smartphone application. So both scored at the same level. In this case, we have to reject this hypothesis. Mainly, we have to reject the hypothesis because we had this layered approach that the tangible augmented reality application is better than smartphone, then the smartphone is better than the worksheet. So yeah, most of the time, the two digital applications were at the exact same level. For motivation, we had a significantly lower pressure and higher enjoyment with both digital learning applications, so with the augmented reality application and the smartphone, than with the worksheet. But once again, here we had no difference between the two digital versions. Cognitive load, no difference between the three conditions. So once again, we have to reject this hypothesis. But the good thing about this one is the cognitive load was not higher than with the worksheet. So we did not have a higher cognitive load because we gave the plush toy to the students instead of just having a worksheet that they just have to work through. So it's not making it worse, which is also already a good result out of this. And finally, for the feedback, the students were allowed to give grades to the learning applications, and the students gave significantly better grades to the digital learning applications than to the worksheets, because, well, as we just have seen, they were in total more motivating and more emotional activating than the worksheet. So what are the overall results? Well, the learning effectiveness is comparable to traditional methods, which is already a good thing. So it's not really distracting the students from the learning content. They can focus on the learning content. They can acquire new knowledge. And there is even a good positive outcome considering the learning experience itself. So there's an emotional positive benefit. Students were just enjoying it more and were more emotional positive activated when learning. And they even had a higher motivation to learn, which is already a good effect. I mean, even if the learning effectiveness is the same, they still have maybe a better memory of the results, or a better memory of the entire learning period, which hopefully increases a little bit the relevance of that learning content for them. So what are the implications? Basically, we came rather to the conclusion that this tangible augmented reality learning environment is definitely more complex to handle than a simple smartphone application. So it should be used rather carefully by using it for hard to comprehend subjects, for subjects that maybe need a very good motivation, that need a very good introduction, where students really can then play around, can already start to learn about the learning content. And for all the other use cases, the smartphone learning environment already achieves a higher student activation, and hence it is already a good step into the right direction. So yeah, considering the fact that teachers also need to prepare everything, considering the fact that there needs then to be a huge box of plush frogs in order to just convey the fact of biology. So I guess it's easier than to just simply go for a smartphone application for, well, not too hard to comprehend subjects. And yeah, the future work would be to definitely go to head-mounted display augmented reality to, on the one hand, increase the immersion, and on the other hand, to have the hands-free of the students, because so far they, of course, had to operate the smartphone with one hand and the extractable markers with the other hand, and this makes it a little bit more complicated. And we also want to continue to play around with the actual markers. So instead of having these cutout markers that are just paper-based, we want to use 3D printers to play around with 3D printed organs to just see if this more haptic experience also has an effect on the learning experience and on the overall perception of the system. And with this, I'd like to thank you for your attention, and I'm happy to take any questions.
Thank you, Sebastian, for your Superfrog. It's very interesting. And well, some questions for Sebastian.
I have.
Hi, Bert.
Hello.
Hello.
The first one is it openly available? It's so cool.
Yes. I can after finishing the presentation put a link into the description into the chat of the Zoom call, and I hope we also added the link to the paper itself, so even there should be the link. But I will definitely put you a link into the chat that you can quickly check it out. Of course, the plush frog itself, not easily downloadable, so there you have to put in some creativity, but the smartphone application as well as the just print out augmented reality version is publicly available, so you can just use it, and it runs on any Android device, so should be good for you.
Oh, yeah. And a second question, are you part of the Discord? I tried to find you, but maybe my Discord skills are not good enough.
I haven't joined Discord yet, to be honest, so I will join Discord after the presentation. So
if not, I can write you a mail, but
this would be also great. I mean, you can also write me an email, and if you like, we can also set up a Zoom call later on, or so, whatever you like. I'm always open for any kind of exchange.
Thank you.
Okay, thank you. Anybody have questions for Sebastian? Sebastian, one question for we to move for the next presentation is I have more, but this is one question that I like to make to you. In terms of immersive learning, this different the smartphone, the hardware, what is the who can see how students immersing the learning? You can see this difference or not see this difference in terms of immersion. You understand my question? Or
do you, in this case, do you refer to the immersion more from the
yes,
science perspective, so being absorbed by the activity itself, or from the technical point of view as we do it from
in terms of tasks, in terms of learning, how the students immersion in this Superfrog, and what is the difference?
I mean, it was more like they were really excited to just play around with it. I mean, it was hard to, in this case, really figure out their absorption. It was more interesting to already see at the start of the each experimental trial, because they were assigned randomly to each condition, and students were really disappointed when they ended up with a paper group instead of the plush frog group, and so they were really excited about this. And from the we also had a lesson learned a little bit with respect to the 6th grade students, because for them it was sometimes a little bit more difficult to operate the plush frog, because it's a little bit unwieldy, it's a little bit hard to hold in their hands and so on. And so there, the smartphone application, where we just have basically the 3D model of the frog being displayed, was way better for them, because there they really could just play with the plush frog and learn about its organs, instead of having to do so much more manipulation and exchanges and so on. And also there is a little bit the problem that to some degree, some mental rotation skills or rotation skills in general start to develop a little bit later than in the 6th grade. So with 12, you do not have all these skills fully developed yet. And so there were also some issues like, do they now need to rotate the camera, or do they need to rotate the object? So there was also some issue for them to comprehend how to operate the learning application. And so in the end, they were most immersed, of course, in the 3D environment. But I think this is also a little bit an issue of our target group. So when we did experiments with normal students, university students, they were totally amazed by the plush frog and were completely happy playing around with it and taking it apart.
Okay, thank you, Sebastian.
Well, thank you, everybody. I hope you enjoy the rest of the conference.
Thank
See
you.
you, Shari.